The National Electrical Code, or NEC, does not contain a specific section dedicated to color coding for nominal voltages. The color coding practices, such as black, red, and blue for 120/208 volt systems and brown, orange, and yellow for 277/480 volt systems, are derived from established industry standards and practices. One important standard is ANSI/NEMA WC 3.2022, which stands for the American National Standards Institute and the National Electrical Manufacturers Association. This standard specifically addresses the color coding of electrical conductors for low-voltage power distribution systems. It outlines the colors that are commonly used for different voltage levels, including the aforementioned colors for both 120/208 volt and 277/480 volt systems. Another relevant standard is IEEE Std 141.2019 from the Institute of Electrical and Electronics Engineers. This standard offers guidelines for electrical power distribution systems, and it also includes the color coding scheme that is commonly used. The specific origins of these color coding practices are not explicitly documented in the standards themselves. However, it is generally understood that the practice evolved from the early stages of electrical distribution. Initially, different colors were used to identify various circuits or voltages. Over time, these color codes became standardized in order to ensure consistency and promote safety in electrical installations. Standardized color coding is crucial for several reasons. Firstly, it allows electricians and other qualified personnel to quickly and easily identify the voltage level of a conductor. This is particularly important when working on or near energized equipment. Secondly, it reduces the risk of accidental contact with the wrong voltage, which can lead to electrical shock or other injuries. Thirdly, standardized color coding helps to prevent miswiring, which can cause equipment damage or even fire hazards. While the NEC does not mandate specific color codes for nominal voltages, it does contain requirements for the identification of conductors in general. For example, Section 200.6 of the NEC requires that the grounded conductor, also known as the neutral conductor, be identified by a continuous white or gray color. This requirement helps to prevent the accidental connection of a hot conductor to ground, which can create a short circuit. In addition to the grounded conductor, the NEC also requires that the equipment grounding conductor be identified by a continuous green color or a green color with one or more yellow stripes. This requirement helps to ensure that equipment is properly grounded, which is essential for protecting people from electrical shock. Although the NEC does not specifically address the color coding of nominal voltages, it is important to follow industry standards and best practices when installing electrical systems. This will help to ensure that the system is safe, reliable, and easy to maintain. In summary, the color coding of nominal voltages is not specifically addressed in the NEC. However, industry standards such as ANSI/NEMA WC 3.2022 and IEEE Std 141.2019 provide guidelines for this practice. The color coding scheme that is commonly used, such as black, red, and blue for 120/208 volt systems and brown, orange, and yellow for 277/480 volt systems, evolved from the early days of electrical distribution and has become standardized over time to ensure consistency and safety. It is crucial to follow these standards and best practices when installing electrical systems to ensure their safety, reliability, and ease of maintenance. Beyond the general color coding schemes, it's beneficial to understand how these standards apply in different contexts, such as residential, commercial, and industrial electrical systems. In residential wiring, for instance, the 120/208 volt system, often supplied as single-phase 120/240 volt, the black, red, and blue color coding is prevalent. Black typically represents the hot or live wire, red is often used for a second hot wire in a multi-wire branch circuit, and blue may be used for switch legs or control wires. The neutral wire is always white or gray, and the grounding wire is green or bare. In commercial settings, both 120/208 volt and 277/480 volt systems are common. The 277/480 volt system with its brown, orange, and yellow color coding is often used for powering lighting and HVAC equipment. It's important to note that while these color codes are widely accepted, local codes or specific project requirements may dictate alternative color schemes. Always consult the relevant electrical codes and project specifications before commencing any electrical work. Furthermore, consider the implications of using different wiring methods. For example, in conduit systems, individual conductors are often pulled through the conduit after it's installed. This allows for flexibility in wiring and makes it easier to change or add circuits in the future. In contrast, cable assemblies such as NMB cable have conductors that are pre-assembled and sheathed in a protective jacket. This type of wiring is typically used in residential applications and offers a cost-effective solution for wiring branch circuits. The choice of wiring method can also impact the color coding requirements. For instance, in some cases, it may be necessary to re-identify conductors at their terminations to comply with the NEC or local codes. This can be done using color-coded tape or other approved marking methods. Safety is paramount when working with electrical systems. Always to energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. It's also important to understand the potential hazards associated with arc flash and arc blast, which can occur when electrical equipment fails or is inadvertently short-circuited. Arc flash is a dangerous condition that can produce extremely high temperatures and intense light, while arc blast is a pressure wave that can cause severe injuries. To mitigate these hazards, it's essential to follow safe work practices, such as wearing arc-rated clothing and using insulated tools. Additionally, consider implementing arc flash studies to assess the potential hazards in your electrical system and determine the appropriate protective measures. Understanding the principles of grounding and bonding is also crucial for electrical safety. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting different metallic parts of an electrical system together, which helps to equalize their potential and reduce the risk of electrical shock. The NEC contains detailed requirements for grounding and bonding, and it's important to comply with these requirements to ensure the safety of your electrical system. Regular inspections and maintenance are also essential for maintaining the safety and reliability of electrical systems. Inspect electrical equipment for signs of damage or wear, and replace any worn or damaged components promptly. Test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, regularly to ensure that they are functioning properly. These devices are designed to protect people from electrical shock and prevent electrical fires, respectively. In addition to the color coding of conductors, it's also important to understand the marking requirements for electrical equipment. The NEC requires that electrical equipment be marked with specific information, such as the voltage rating, current rating, and horsepower rating. This information helps to ensure that the equipment is properly installed and operated, and it can also be useful for troubleshooting purposes. When working with electrical equipment, it's important to follow the manufacturer's instructions and use the equipment only for its intended purpose. Overloading electrical circuits or using equipment that is not properly rated can lead to equipment damage, fire hazards, or electrical shock. Finally, consider the impact of energy efficiency on electrical system design and operation. Energy-efficient lighting, motors, and other electrical equipment can help to reduce energy consumption and lower utility bills. The NEC contains requirements for energy-efficient electrical systems, and it's important to comply with these requirements to minimize energy waste. In summary, understanding the color coding of nominal voltages is just one aspect of electrical safety and compliance. It's also important to be familiar with the NEC industry standards, safe work practices, grounding and bonding principles, equipment marking requirements, and energy efficiency considerations. By following these guidelines, you can help to ensure the safety, reliability, and efficiency of your electrical system. Remember that electrical work should only be performed by qualified personnel who have the necessary training and experience. Improper electrical work can be dangerous and can lead to serious injury or even death. When in doubt, consult with a licensed electrician or other qualified professional. The information provided here is for general educational purposes only and should not be considered as a substitute for professional advice. The world of electrical engineering continues to evolve, with advancements in technology and changes in regulations. Staying up to date with these developments is crucial for electrical professionals. This can be achieved through continuous learning, attending industry conferences, and participating in professional organizations. New technologies, such as smart grids, renewable energy sources, and electric vehicles, are transforming the electrical landscape. These technologies require new skills and knowledge, and it's important to be prepared for these changes. Smart grids, for example, use advanced sensors, communication networks, and control systems to improve the reliability, efficiency, and security of the electrical grid. Renewable energy sources such as solar and wind power are becoming increasingly important as the world transitions to a cleaner energy future. Electric vehicles are also gaining popularity, and they require charging infrastructure that can support their growing demand. The NEC is constantly updated to reflect these technological advancements and changes in regulations. The NEC is revised and published every 3 years, and it's important to stay current with the latest edition. The NEC contains numerous articles and sections that address specific aspects of electrical installations. It's essential to be familiar with these articles and sections to ensure compliance with the code. The NEC also contains tables and examples that can be helpful for understanding and applying the code requirements. These tables and examples provide practical guidance for electrical professionals. In addition to the NEC, there are other industry standards and guidelines that can be useful for electrical professionals. These standards and guidelines cover a wide range of topics such as electrical safety, equipment installation, and system design. Some of the organizations that develop these standards and guidelines include the IEEE, the National Fire Protection Association, or NFPA, and the American National Standards Institute, or ANSI. It's important to be familiar with these organizations and their publications. Electrical safety is a critical concern for electrical professionals. Electrical hazards can cause serious injuries or even death. It's essential to follow safe work practices and use appropriate personal protective equipment when working with electrical systems. Some of the common electrical hazards include electrical shock, arc flash, and arc blast. Electrical shock can occur when a person comes into contact with an energized conductor. Arc flash is a dangerous condition that can produce extremely high temperatures and intense light. Arc blast is a pressure wave that can cause severe injuries. Personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing, can help to protect electrical workers from these hazards. It's also important to energize electrical circuits before working on them whenever possible. Lockout/tagout procedures can be used to ensure that circuits are not accidentally energized while work is being performed. Effective communication is also essential for electrical safety. Electrical workers should communicate with each other to ensure that everyone is aware of the potential hazards. Clear and concise instructions should be given before any work is performed. Electrical apprenticeships and training programs play a vital role in preparing the next generation of electrical professionals. These programs provide hands-on training and classroom instruction in electrical theory and practice. Apprentices learn from experienced electricians and gain the skills and knowledge necessary to perform electrical work safely and effectively. Upon completion of an apprenticeship program, apprentices typically become journeyman electricians. Journeyman electricians are qualified to perform electrical work under the supervision of a master electrician. Master electricians have extensive experience and knowledge in electrical systems and are authorized to supervise other electricians. Continuing education is also important for electrical professionals. Electrical technology is constantly evolving, and it's essential to stay up to date with the latest advancements. Continuing education courses can help electrical professionals to expand their knowledge and skills. These courses may cover topics such as new electrical codes, energy-efficient technologies, and advanced troubleshooting techniques. Ethical conduct is also an important aspect of being an electrical professional. Electrical professionals should always act with integrity and honesty. They should adhere to the highest ethical standards and avoid any conflicts of interest. Electrical professionals have a responsibility to protect the public safety and welfare. They should always prioritize safety over profit and avoid any actions that could compromise the safety of others. By upholding these ethical principles, electrical professionals can maintain the trust and confidence of their clients and the public. Understanding the fundamentals of electrical theory is essential for electrical professionals. Electrical theory provides the foundation for understanding how electrical circuits and systems work. Some of the key concepts in electrical theory include voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit. Current is the flow of electrical charge through a circuit. Resistance is the opposition to the flow of current. Power is the rate at which electrical energy is transferred. These concepts are governed by Ohm's law, which states that voltage is equal to current multiplied by resistance. Ohm's law is a fundamental principle of electrical theory and is used extensively in electrical calculations. Electrical professionals should also understand the principles of alternating current, or AC, and direct current, or DC. AC is the type of electricity that is commonly used in homes and businesses. DC is the type of electricity that is produced by batteries. AC circuits are characterized by a sinusoidal waveform, while DC circuits have a constant voltage and current. Understanding the characteristics of AC and DC circuits is essential for designing and troubleshooting electrical systems. Electrical professionals also need to be proficient in using electrical test equipment. Electrical test equipment is used to measure voltage, current, resistance, and other electrical parameters. Some common types of electrical test equipment include multimeters, clamp-on ammeters, and insulation resistance testers. Multimeters are versatile instruments that can measure a variety of electrical parameters. Clamp-on ammeters are used to measure current without having to break the circuit. Insulation resistance testers are used to measure the resistance of insulation materials. Using electrical test equipment properly is essential for ensuring accurate measurements and preventing electrical hazards. In addition to electrical theory and test equipment, electrical professionals should also have a good understanding of electrical codes and standards. Electrical codes and standards are developed to ensure the safety and reliability of electrical installations. The NEC is the most widely adopted electrical code in the United States. The NEC is updated every 3 years to reflect changes in technology and safety practices. Electrical professionals should be familiar with the NEC and other relevant electrical codes and standards. Compliance with electrical codes and standards is essential for ensuring the safety of electrical installations.